Okay, we're going to look into solving radical equations right now. This section is probably many things you've actually done before in this section, to tell you the truth. So this video shouldn't take us terribly long. There's really only two problems I want to look at, and a few things I want you to watch out for. But a lot of this is material you have probably seen before. It's just now we're ramping it up a little bit. There's no new, radically new ideas here. Okay, so first of all, when you're solving radical equations, these are the things that you want to be doing. First thing you need to do is isolate the radical on one side of the equation, if necessary. That means that you have to have a square root or a cube root or whatever root it is on one side alone, nothing else over there. So I can't have something like square root of x plus 1 minus 2 equals 9. Okay, that's not cool. I'd need to make sure that the x plus 1 was by itself on one side of the equation. Okay, raise each side of the equation to the same power to eliminate the radical and obtain a linear, quadratic, or other polynomial. Again, if you want to eliminate a square root, you square it. If you want to eliminate a cubed root, you cube it. And what I do to one side of the equation, I must do to the other side of the equation. Okay, and you're going to end up with something that doesn't have any square roots in it eventually. Then we'll solve the polynomial using techniques we learned in previous sections. And then I meant to highlight this, or to bold this as well. You need to make sure you check your solutions. That's vitally important. Okay, let's look at a couple problems. The first one is the cubed root of 2x plus 7 equals 3. Okay, so the first thing I need to do is I need to isolate the cubed root equation over here. Now notice this is already isolated. So in this case, step 1 is already done for us. The cubed root is on the left and numbers without cubed roots are on the right. That's good. So that's step 1. We've finished step 1. We don't have to do any work here. Step 2 is to cube both sides. And you really do need to get in the habit of writing out every intermediate step. Okay, so cubed root cube, that means the root goes away on the left, and on the right, I have 27. Because 3 times 3 times 3 is 27. Now I'm going to solve. I'm going to go 2x equals 20, and x equals 10. Alright, last thing I need to do is check my solution. I need to plug this back into the original equation. You can't plug in and up here, you have to plug it back into the original. So I go the cubed root of 2 times 10 plus 7 equals 3. Let's double check and make sure this works out. So I get the cubed root of 2 times 10 is 20 plus 27. Is the cubed root of 27 3? It is. Good. So this works. Let's look at another one. Okay, again, the first step is to make sure that square roots or cubed roots, all the roots are on one side, okay? Or not that they're all on one side necessarily, but that we have something equal to a root, okay? So for instance, this would be okay too. X equals square root of 2x minus 1. This would be okay. What I need to make sure is that I have the root by itself on one side. If I have roots by itself on both sides, that's going to be okay as well. But we need to make sure that in a case like this, we have the root by itself on one side. There are going to be cases where we can't do that and we just have to deal with it, but whenever we can, we do that. So I have the root by itself on one side. Oh. Alright, so now what I'm going to do is I'm going to square both sides in order to get rid of the square root. I get x plus 1 squared. Now remember, I have to FOIL this. X squared plus 2x plus 1. I can't simply write x squared plus 1. That's different. And on the right, the square root and the square undo each other. I'm left with 7x plus 15. Now I have to solve this. Now I have to go back to my knowledge of polynomials, quadratics. I'm going to pull this to the left-hand side, and I'm going to get x squared minus 5x minus 14 equals 0. And I'm going to solve this. I'm actually going to factor this. X. Okay, if I do negative 7 and positive 2, I'm going to get 0. So that means that my solutions are x equals 7 and x equals negative 2. Now I have to check them. Alright, so I'm going to plug in 7. If I plug in 7, I get 7 plus 1. I have to plug it into the original equation. Equals the square root of 7 times 7 plus 15. So 8. This is going to be 49 plus 15. Is that 64? It is. That works out. So 7 is definitely a solution. Let's try plugging negative 2 in. If I plug in negative 2, I get negative 2 plus 1 equals square root of 7 times negative 2 plus 15. On the left, I have negative 1. We're already looking a little strange here. On the right, I have negative 14 plus 15. And on the right, this is the square root of 1, but 1 does not equal negative 1. So negative 2, even though when we do our algebra, we get it as a solution, does not count as a solution. That's why we have to check our solutions. The only solution to this equation is x equals 7. Okay, so that checking your answer step is vitally important. Okay, so that's it. We're going to do some more practice in class to hopefully clear some of these other little points up.